Now let's move on to loading the data and getting a few parameters out of the data. You already have the code here that does this part of the exercise, but let's move step by step. So although you have completed this part, I want to go over it just for the sake of completeness. So you load this data from sklearn datasets. While we are waiting for this to load, I want to show you that this dataset, iris dataset, can come in different formats. More specifically, the class labels in some sources, for example, this is a popular data source, UCI data sets website. Here all the features are numeric, no problem there. This is a comma separated value file, you can read this. But the only thing is the class labels are kept as text fields. So if your application, if your implementation expects a numeric class value like 0, 1, 2, you have to convert these text values to numeric labels yourself. So that can be an issue in loading your data, and you have to be aware of. So we have our data here. So let's first load it. So if you just type iris, you can see all the fields of this data. There is a description, there is the data itself, consisting of the X part of the data, the features. You can see the names of the features. Then there is the target, which is the class labels 0, 1, 2, and you can have access to names of the classes in another area. So these are all accessible through fields or as data fields of the variable. So first we get the X part. So X is a array, 4 columns. We can see 4 columns. Actually, X is a numpy array, ND array. So you can use parameter or fields, data fields like shape. So this is 150 samples of 4 features. This is available here. And let's get Y also. Y is stored in the target member area. So Y again is an array. It's a numpy array again. And something important here, you can see that it has 150 elements, but it's one-dimensional. You don't see the second number here. We learned that there is a subtle difference between a one-dimensional array of 150 elements versus a two-dimensional array of size or shape 150 by 1. If there was a 1 here, you would call this a column vector. It would be a two-dimensional array which is shaped like a single column. But this is a one-dimensional array, and that can cause problems in some implementations if you're not careful. So this has one dimensions, but X has two dimensions. You will see how this affects your implementation, and actually you have a problem in your implementation just because of this. So let's explore the values. You can check the minimum and maximum of Y. A shortcut to see all the distinct values or all the unique values in Y is to construct a set out of it. So you can see that all the values in this Y vector are 0, 1, or 2. We have 3 classes, and these are the values. So these are just verifying or checking some parameters that we already know about, but this is a good exercise to get familiar with the data structure we have here. So as I said, there are other useful fields, like you can get the names of the features or names of the classes, target names, and finally there is the description part. It doesn't appear nice here, but you can have a nice printout of this, which could be helpful. So we know the number of features. It is equal to the number of columns of X. We know the number of classes. It is the number of distinct values in Y. And we know the number of samples. It is the number of rows of X, which should be equal to the number of rows of Y.